Hi everyone, this is Mrs. Keener, and today we're going to do square root functions, graphical and analytical approaches. So we've already looked at absolute value and quadratic, and now we're on square root. You see the a in front and then the h and k. So you should become familiar with those because it's going to be very, very similar. Consider the square root function f of x equals the square root of x plus 2, and then the plus 1's on the outside. Do you see how the plus 2 is inside the square root? We're going to complete the table of values below just by plugging in numbers and finding the y value. Show your work, find each missing value, and then graph and connect the points for f of x. Y'all ready? Here we go. Finally, we have enough room to show our work. So f of -3 means we're going to plug in -3 for x. Now, simplify under the square root, kind of acts like parentheses. We're going to do that first. -3 plus 2 is -1. So we have a square root of a -1. Now, we haven't really learned how to do that yet. Or you may have seen it, you may not, but this is actually no real solution. So we can't actually plot a point at -3 because it doesn't exist in the real numbers, which is what we graph with. All right, don't give up. Try again. Let's plug in -2 now. The square root of -2 plus 2 plus 1. All right, what's -2 plus 2? 0. And the square root of 0 is 0. So we have 0 plus 1, 1. Next one, -1. -1 plus 2 plus 1. All right, I'm going fast, but that's okay. You can catch up. What's under the square root? We have -1 plus 2, so it's going to be a 1. What is the square root of 1? 1, and 1 plus 1 is 2. Keep going. Plugging in 2 now. 2 plus 2. Hold on, look at this table. Did this go in order? Does it go by integers? I mean, it's in order, but is it increasing? But did we go by ones? No, so we skipped over some numbers, and I wonder why we did that. Let's see. 2 plus 2. 2 plus 2 is 4. Square root of 4 is, do we know the square root of 4? Yeah, the square root of 4 is 2. So we have 2 plus 1. What's 2 plus 1? 3. So here we had a square root of 0, a square root of 1, and a square root of 4. Do you see how all these are perfect squares? So do you think I picked these x values on purpose? Yeah, I picked them on purpose so that we would have perfect squares and not decimals for this example. Can we plug it in the calculator and find a decimal if we wanted to? Yeah, of course we could. 7 plus 2. All right, what do we have here? What is 7 plus 2? 9. Do we know the square root of 9? Yes, the square root of 9 is 3. 3 plus 1 is 4. Here we go. We're going to graph these. Ready, get set. First point. We can't graph it, so don't put a point. Next point. -2, +1. Next point. -1, +2. All right. 2, +2, +3. 7, 4. So we're going to go all the way out to 7 and up to 4. Okay, now, didn't we say there are no points at -3? What about if you plugged in -4? That would also be undefined. What about -5? Undefined. -6. All of those would give you no solution. So actually, this graph begins at this point. It's like the starting point of the graph. So you remember in geometry when you had, remember this was a ray? I should have asked you, what is that called? You go, ray, and I say, good job. It's similar to that. It's like a curved ray. It starts at a single point, and then it offshoots like this. I call it an arm. Reminds me of like a scarecrow's arm hanging out. I'll show you in class, okay? But do you know what this actually is? Turn the paper. What does that remind you of? Does it remind you of half of a parabola? Yep. Where's the other half? I don't know. It's in mysterious world. Just kidding. This is graphing a positive square root. If we were to graph a negative square root, if we had a negative in front of that, it would give you the bottom half of the parabola. Let's just worry about this. Square root functions. Are we here? Is it beautiful? It should be, this is a ray from geometry. It's a straight line. A square root function will look like this, like a scarecrow's arm. I don't know, that's what I think of. What is a domain? Will this hit every single x value from negative infinity to positive infinity? No. Where are the x values? No, 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 no. Here. What x value is that? -2. And then they go what? They go greater than -2. Is it equal to -2? Yes. So the domain are going to be all x greater than or equal to -2. This is an introduction. Range. Range are y values. Is the graph down here? No, nope, 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 nope. Ding, 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 ding. What y value does the graph begin? At y equals 1. So all the y's, and then are they above 1 or are they below 1? They're above, right? All the y's are greater than or equal to 1. Identify the coordinates of the starting point. The starting point is very similar to the vertex, what we talked about with parabolas or absolute value. So where did this start? What is that coordinate point? -2, 1, right? Hey, what's the value of a? Let's see, what does a mean? A is a number in front. What number is in front of the square root here? I don't see anything. Is that 0? Nope. A is equal to 1. So what is the value of a? Ready? A equals 1. Then describe the location of the first 3 points to the right of the starting point in relation to the starting point. Describe the relation of the first 3 points. So the first point went up 1 over 1. I don't know what color to use. Here we go. I'm going to use a red. Up 1 over 1. The second point, are you ready for this? It's going to be crazy. I hope you guys can figure this out. Ready? The second point, ready? Up 2 over 4. So we had 1, 1, and then we had 2, 4. Okay, watch the third point. Up 3 over, I don't know, how much is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 1, 1, 1, 2, 4, 3, 9. What? That's kind of like rise over run, yeah? Slopes. But what are the slopes? It's not linear, so it's not a constant slope. How does the 1 become a 1, and the 2 become a 4, and the 3 become a 9? What? They're like being squared, right? I shouldn't use the x. Do you agree they're being squared? Okay, so that actually follows the pattern of the parabola. 1, 1, 2, 4, 3, 9. Isn't that cool? I just described it out loud. How do I describe it here? Let me think. Why don't I just write down like the pattern? 1, 1. How about that? 1, 1. And then we went up 2 over 4. And then up 3, not drawn to scale, over 9. Like, is that 3 and 9? No. We get the idea. Set h, x minus h is greater than 0. Okay. Where is x minus h? Let's see. X minus h is what's inside the square root. X minus h here is x plus 2. So we're going to take that inside, and we're going to say x plus 2 is greater than or equal to 0. I wonder why we're doing that. Why are we doing that? What's the rule for square roots? You can only take the square root of a positive, right? But we don't use the plus sign for positive. What does positive mean in math? Positive means greater than or equal to 0. So this will only be defined if the inside is greater than or equal to 0. If you said square root of a plus sign, that's like middle school, but we don't really say that anymore. So x plus 2 must be greater than or equal to 0 in order for us to get a real solution, whereas here we got a no solution. Back down here. This is a lot, yeah? Your brain's hurting a little bit? It's okay. Stay along. Why did we do that? I don't know. We just followed directions, right? Let's see. What does this match in the row above us? This is what? The domain. Do you see that? Domain. Now it says set h minus 0 equal, sorry, you can read. When I read, I get it wrong. X minus h is the inside, and the inside is x plus 2. X plus 2 equals 0, and then what? Solve for x. Okay. Yes, ma'am. Yes, sir. What? Oh, what is the value of k? Where's k? K is a number on the end. What's our number on the end? 1. K equals 1. Hi, friends. What do you notice here? What do you notice about when you set the inside equal to 0? Where is that negative 2? Do you see it here? And the k value is 1. Do you see it here? And what was this point? It was like, what was it in the absolute value and the parabola? It was the vertex, right? But for a square root, it's going to be the starting point. So much math, so little time. What are our conclusions? How do you find the starting point of a square root function if it's in that form? So to find the x value, you set x minus h equal to 0 and solve for x. That's kind of wordy, but to find the y value, well, the y value is the k value. So that's kind of easier. See that? The y value of the starting point was the k value, but to find the x value, you have to set the inside equal to 0 and solve for x. Inside of the square root. Inside of square root. It does have a special name. We're going to get to that later because, yeah. For square root functions in which a is equal to 1, describe the point pattern of the 3 points to the right of the starting point. So only because a equaled 1 in this case, absolute value, so it could be positive or negative, describe the point pattern. So the point patterns actually matched the squares up to 2 over 4 and then up 3 over 9. So they match the perfect square, perfect square pattern, S-Q-U-A-R-E, perfect square pattern, similar, ooh, geez, I'm having a bad day, similar to parabolas. All right, these are some notes. How's everyone doing? I have a minute left and I don't, oh, mine got stapled funny. Example 2. We're going to get going on this, and then I want you guys to finish and do as much of this as you can using the example 1 as an example. And then we will start class by finishing this up together. Okay? But first thing we have to do is plug in the points. So what's different about this one? We have that negative 2 in front, so it's going to look a little bit different. I'm going to do as much as I can in the minute I have left. So what you're going to do is finish this page to your best ability. If you can do it, then you don't need us. You don't need us to explain it. Hi. Do you agree we have a square root of a negative 1? So will we get a real answer here? Nope. So no solution. And that's okay. Let's plug in negative 4. I think I need more room. So negative 4. Oh, what's negative 4 plus 4? 0. What happens when you have negative 2 times the square root of 0? 0. What do we get? 6. Negative 3 plus 4. What's going to be under our square root now? Now we're going to have the square root of 1. So negative 2 times the square root of 1 is just, the square root of 1 is 1. So 1 times negative 2 is negative 2, and then plus 6 is 4. Okay, so finish this to your best ability.